All right, for number 74, Raider total ticket sales for an upcoming game were recorded over the past 7 days. The number of total tickets sold by Friday, the week of the game, are in the table below. So first off, it says graph the data from the above table on the grid below. Now, you can make your scale anything you want to. So down here, I was counting by halves. You could have counted by ones or fourths or whatever you want. You just have to be able to get 1 through 7 on there. And then over here, I've got to make it all the way up to 4,900. So definitely not counting by ones or twos, right? So for this one, you can see I'm counting by hundreds, and I don't want to have to go from 100 to 2,500. And so I can put this little squiggle in here that lets me skip. So then we can count by the 100s. You need to indicate what your scale is. Like you can see, because this is 2,500 and this is 3,000, that's a scale of 100. And then over here, you can see, because it's labeled 1, 2, 3, that this is a scale of 1/2. So just be sure you scale it to however you want, but be sure that you list what some values so we can see what your scale is. Okay, so I'm going to first off graph the data from the table. So I've got 1, 2,500. I've got 2, 2,800. 3, 3,200. 4, 3,700. 5, 4,100. 6, 4,400. And 7, 4,900. All right. Then it says sketch a line of best fit on your graph below. So basically, you just want to draw a line that goes through your points. You are not connecting all of these points. If you connect all these points, that will not be a straight line. That won't be a line of best fit. All right, so that's our approximation of a line that would best fit those points. Our calculator can do a much better job of that. All right, so let's go to our calculator. All right, and so the way that we're going to do this is we're going to go to statistics and we're going to go to edit. It's a good idea to clear out everything that's in your list. So I'm just going to hit clear, enter to clear that whole list. All right, so that first one is 1, 2, 3, 4, 5, 6, 7. And then our second column is 2,500. 2,800, 32, 37, 41, 44, and 49. All right, so once I've got my information in list 1 and list 2, I'm going to quit out of that. And I'm going to go back to statistics and go over to calculate. And they told me that this was a line, but we also graphed it and saw that it was a line. So I'm going to do a linear regression. And I'm going to tell it to use for X what I put in list 1 and for Y what I put in list 2. Now, you don't need to do this part. I'm doing it just so I can show you something in a second. But all you need to do is just come down here to calculate and hit enter. It doesn't matter whether you have these R values down here or not. What you just need is A and B. So it told you to use your graphing calculator to complete a linear regression to create an equation to fit the model and to round to 1 decimal place. So we're going to do 403.6 for A. So that's going to be Y equals 403.6X. Plus B is 2,042.9. All right, so if I went to Y equals and I typed in that equation, I had my calculator do it for me, and then I graphed it. I'm going to go to a Zoom 9, which is my Zoom stat. So you can see there are the points that we plotted on our paper, and that would be the line that the calculator created to go with it. So you can see that is a good line of best fit for that. All right, so I tried to put the steps on your sheet for you here that we just did on the calculator. And so We went to statistics, we went to edit, we went to list 1 and hit clear enter, and then we put those values into list 1. And then same thing, we went to list 2 and hit clear enter, and then we entered our values in list 2. We quit out of that and we went back to statistics, and this time we went over to the right to calculate, and we chose linear regression. And we told it to use for X what we had in list 1 and use for Y what we had in list 2, and then to calculate. And it told us that A was 403.57, which we rounded to 403.6, and that B was 2042.86, which we rounded to 2042.9. So that equation would be y equals 403.6x plus 2042.9, as you see here. All right, then it says use that equation you just got from part C to determine how many tickets will be sold by day 8. All right, so you'll notice the days are up here, and we told our calculator to use that for X and that use these values for Y. So I'm just going to put 8 in the place of X, and that will tell me the ticket sales for that 8th day. And so that would be the 5,271.7. And if we round that to the nearest whole number, that would be 5,272. All right, then our last one down here, if y varies directly with x squared and inversely with the cube root of z when y equals 4, x equals 2, and z equals 8, find the value of y when x equals 3 and z equals 27. Okay, so first off, let's start with y varies directly with x squared. Okay, so we can say y equals directly with x squared. And this is going to be a joint one because here's another thing coming. It varies inversely with the cube root of z. So inversely, remember, means to invert it, to put it down in the denominator. So here's my cube root of z. All right, so then it says y equals 4. So 4 in for y. X equals 2. So 2 in for that x right there. And z equals 8. So 8 in for z. All right, so I'm going to get 2 squared is 4. So 4k here, and then down here, cube root of 8 is 2. So 4 divided by 2 would be 2k, so I'm going to have 4 equals 2k, divide both sides by 2, and I'll get k equals 2. So let's put 2 right there in the place of k, and now I've got my equation, y equals 2x squared over the cube root of z. So here's that equation right here. So it says, okay, now that you have that equation, find the value of y, so we're looking for this guy, when x is equal to 3 and z is equal to 27. So I'm going to put 3 in for x, and I'm going to put 27 in for z. All right, so 3 squared is 9, so we'll have 9 times 2, or 18 in our numerator, and then cube root of 27 is 3, so we can say 18 divided by 3 is 6.